Hello. Hi, good evening, and welcome to today's session. Am I audible?
Yes, you are audible.
Okay, great. Thanks. So I think, Supriya, we can wait for around 1 or 2 minutes. Maybe others will also join, and then we will start.
Yeah, no problem.
Okay, hello. So I think we can start today's session right now. One sec, let me just check whether the recording is on here. Okay, all good. Great. So once again, good evening and welcome to Urban Utilities and Planning, Water Supply, Sanitation and Drainage tutorial session. So we will be dealing with week 7. I think both of you have attended previous sessions, so without much delay, I'm going on to further details. So yeah, so this week, that is week 7, we basically learned about different sanitation methods and sewage systems and what are the different systems which are there, how are they designed and all that. So it was actually a very more theoretical discussion we had in the lectures, and today's tutorial session will also be more of theory based because most of the assignment questions are also theory based. We have very less numericals. In fact, there's only one numerical, and that is also very simple. So yeah, so let's just get started. So as we always, one second, slides not changing. 1 minute. Okay. Wi-Fi is connected, but yeah, cool. So as we always say, we will go question by question, and if you have any doubts, you can stop. You can ask immediately after the question, or after all the questions complete, we'll have a 5 to 10 minutes dedicated for question answer discussions. You can ask related to the questions that we're discussing in this tutorial, or if you have any other doubts, that also you can ask in that last 10 minutes. So yeah, so let's get started. The first question is on it's a match the following. So match the following and mark the correct match. So it mainly talks about fresh sewage, combined sewage, sanitary sewage, and septic sewage, and we have to match. So Supriya, do you want to take this question? Hello? Do you want to answer this question? Am I
Yes,
not?
one
Yeah,
second,
yeah,
please.
sure. I mean, you can just start off like fresh sewage. Which is it? Is it residential discharge from latrines and urinals? Sewage.
Second, sewage recently originated.
Okay, you're saying this is second. Fine.
Combined sewage will be sewerage plus stormwater. Four,
Okay, fine.
sanitary and septic.
Sanitary sewage and you have septic sewage also now. Any guesses?
Septic is sewage undergoing treatment, and sanitary is first one.
Okay, so this is what you're saying. Fine, yeah. So okay, it makes sense also. You have the fresh sewage which will be your recently originated. Yeah, that's why it's called fresh sewage. And then you have combined sewage which will have both. That is combination of sewage and stormwater. So what is sewage, by the way? We're talking about sewage. So what is sewage? What is sewage?
Any sort of liquid waste or liquid mixed with some slurry.
Exactly. Exactly. So basically, all kinds of liquid waste come under sewage. So here, in our discussions about sanitation, we are mainly talking about waste from urinals, latrines, washrooms, etc. And what is stormwater?
It's rainwater only.
Yeah. So any
The
form.
runoff.
Yes, Anurag.
The rainwater runoff.
Yeah. So it's basically we discussed when we were learning about stormwater recharge structures and all that. So it is any form of precipitation. That it can be rain, it can be snow, but mostly we are talking about rain only in the context. Snow, we do all the calculations, everything separately. So yes, so when you have a combined sewage, it will have both combination of sewage and stormwater. And sanitary sewage, yeah, so it is from yeah, so this is from here. Okay, sorry, I marked it wrong. Yeah, so sanitary sewage, it will be coming from residential discharge and latrines, and septic sewage is something which is undergoing treatment. So Supriya is right. So which makes which option would it be then? So option one, four, it's option D, right? Yeah. So let's just, so this is what we learned in our lectures also. I've just put it here. So we have, whatever we discussed. So sewage will be, it is, as Anurag rightly said, it's a liquid waste from any community. And we've just discussed this. What is combined sewage? What is sanitary sewage? And so then there's something called sullage also, which comes, which is the wastewater from bathrooms and kitchens. So which we also called as grain water. So this mainly, sanitary sewage mainly considers only latrines and urinals. From bathrooms and kitchens, we call it sullage also. So this we have already learned. So this question was based on this one. Any doubts on this particular question? Anybody?
No.
Okay, we can proceed further. So the second question is, which of the following parameters constitute the concept of totally sanitized cities? And multiple answers can be right. So, Anurag, do you want to take up this question?
It it should be open, defecation free.
Okay, so you're saying this is right. Yes, it should be open defecation free.
And then there should be municipal sewage and stormwater drainage management as well. The second one
Okay.
also.
So this also should be there. Yes.
Recycling and reuse of treated sewage for non-potable application. Yeah, it can be done.
Okay, it can be done or it has to be done. Like for a totally
It has to be done. It has
sorry,
to
I
be done.
went to the answer by mistake. I'm sorry. Yeah, it has to be done. Yeah. And the last one?
Yeah, definitely improve public health outcomes and
Yeah,
environmental standards to
exactly.
be met.
Yes, exactly. So it's all the answers are right. Like so, basically, we're talking about totally sanitized city. So all aspect needs to be covered. So Anurag is absolutely right. So here, this is what we discussed in our lecture also on total sanitized cities that it should be open defecation free. Then, so in addition to whatever was there in the option, there are other factors such as no manual scavenging should be there, and safety equipment for sanitation workers should also be maintained. So for worker quality and worker health hygiene is also given importance in total sanitized cities. And yes, so this was one of the option. Municipal sewage and stormwater drainage should be there. Then recycling and reuse of treated waste for non-potable reasons should also be there, and solid waste management, and also, and in addition, you need to have the services to poor, improved public health facilities, outcomes, and environmental standards. So these constitute the total sanitized cities, and so this is, as you can see, it's an ideal version, and we discussed in the lecture that we have not been able to achieve 100% of this uh, in most of the cities, but to an extent we have been able to do, and this is one of the mission also, to achieve total sanitized cities and all this, to make all cities totally sanitized. Fine. So the answer is all of the options. Let's go to the next question. Match the following acts with this function. So I think who's ML is joined. No, okay. So it's just two of you. Fine. So Supriya, do you wanna take up this question?
Yes.
Yes. So the Water Act and its amendment, Prevention and Control of Pollution, which will that be? So is it water put to use that demands the highest quality of water?
It
No.
should be prevent and control water pollution and ensure the wholesomeness of water.
First one is
Sir?
for D.
Uh, okay,
C
first, fine.
is
Okay, let's go by what Supriya is saying right now. And maybe after that, Anurag, yeah, we'll come to that. I'll just erase this off. So yeah, Supriya, what were you saying?
D is 1,
So
C
D
is
means
2,
designated best use. You're saying that, okay, water is put to the use that demands it. Fine. And yeah, then
Environment Act is second one,
Environment
protection and
Act means protection and improvement of environment. Okay.
yes,
And then the other two, Water Prevention and Control Act.
prevention and B is 4, A is 3.
B is 4, A is 3. Okay. Right. Yeah. So Anurag, do you have any difference of opinion in these options, or?
No, no, same.
Same, right? Yeah. So actually, this is an easy question. Like, even if we don't know the answer, just by the wordings, we can actually match them. For instance, in the first one, it's prevention and control. It just, and its amendments, the initial one. So we are mainly talking about prevention and control. And the second one, again, a cess act is added. So you're collecting cess. So cess means any tax that you're levying on that particular water that you're consuming. And yeah, so this is environment protection. So you protect it from the environment, and designated best use, you're giving it to the best use. So which is the option which is right? Right, option A would be the correct one in that regard. So yeah, so this was actually an easy question. Supriya, you want to say something?
No,
Okay, okay, sorry, I thought you're saying something. Yeah, cool. So if there are no doubts in this question, we'll proceed further. Okay, we are proceeding further. So yeah, so this was the lecture what we learned. So I'm not going into this because I think the question is pretty clear. So let's not go into this. So next one second. Oopsie. Yeah, so this is what we discussed, and this is the answer. So let's go to question 4. So now open defecation free cities involve access to safe sanitation and waste dash facilities for households. So Anurag, do you want to take this question?
Waste disposal.
Disposal. Okay, you're saying disposal is the answer. Supriya?
same.
Same. Okay, fine. Why not collection? Like, why don't we need to have, it's an open defecation free city. Why not collection? Why not management? Why not treatment?
Open defecation, like collection management and treatment is okay, but if we don't dispose it properly, so that won't be an open defecation free, right? That's why.
Okay, that is right. So, fine. I agree. Disposal is there, but why not all the others also? Is it because you're saying there's only one option, right? So that's why you're going with disposal.
No, if we go for the collection, if you are
Hmm,
collecting the waste, then what are you doing with that?
exactly.
Management is like what you are managing, waste management, sanitation and waste management facilities for household doesn't make any sense.
Exactly. So
And
the yeah,
yes,
yeah, tell, continue.
and for treatment, like treatment is done at the last, like disposal after after the sewerage is in the.
I mean, we have treated it to some extent so that it should be able to dispose of, but the final problems lies with the disposal. You have
Right.
treated the some sewage to some extent, but what is, because there will be some sort of byproduct of the treatment. So where you are going to dump that byproduct, which is not of any use,
and
that is
treat
like disposal after treatment.
Yeah, and treatment is not
So
done
you
for.
have collected, you have managed, you have treated, but most importantly, for a safe and hygienic environment, you need disposal of that.
Okay. I understand that logic. Yes, it all starts with okay, you need disposal, but I do not agree to the so Supriya was right to an extent. That is mainly you're talking about household from a household point of view over here. Safe, you're talking about safe sanitation and waste dash for facilities for households. So when you're talking about a larger scale, like for instance, what the corporation has to do or what it has to be done at a treatment plant or a city level planning, then all this management, treatment, everything will also come into play. But yes, as Anurag was saying, disposal is the most important one, or it is in fact, rather than saying it's a last step, it is the first step. That is disposal. Like we need to first look into how are we going to dispose the whole thing, and based on that only we would be planning how do we collect it, how do we manage it, and how do we treat it. So it all starts with the disposal unit. And if you look here, they've asked mainly for open defecation free cities, that is ODF cities. Then we already learned that there are ODF, then there's ODF plus, and then there's ODF plus plus cities. So this treatment and management mainly comes in this ODF plus cities. That is after disposal, we have sorted disposal, then we are going on to higher level things on how do we manage it, how do we treat it, and how do we reuse it, or what is the other next process that we do. So coming to the slide, this is what we learned about different open defecation free cities. So the main open ODF protocol mainly talks about that we need to dispose of all the waste, and it should not be just lying out everywhere anywhere. And then when it comes to ODF plus plus, there we have all that it should be managed and treated well, and it should not be dumped anywhere. And all the sewage, so all the pipelines laying and all that will come into this ODF plus plus protocol also. So yes, so you're right. Disposal is the most important factor. Okay? Any doubts? Let's proceed further. So now match the following organizations with its responsibility concerning sewerage and sewage treatment. So ML has joined. ML, are you audible? Can you? Okay. So maybe Anurag, do you want to take this question up?
Okay. The Ministry of Housing and Urban Affairs. So for them, I guess maybe they need to like, according to me, the last one, the fourth one, they should formulate policies and provide technical assistance to the state and ULBs.
Okay. And
And mm, the Ministry of Drinking Water and Sanitation, they should be responsible for planning and funding and coordination of drinking water and sanitation program. Then NGOs will be responsible for programs of capacity building, micro level management of people on behalf of the government.
okay.
And yeah, the regulators, independent monitoring of other agencies, NGOs, and ULBs to ensure
Yeah.
compliance of existing norms and regulations.
Yeah, last one. Okay. So this again is a kind of straightforward question. So mainly you're talking about the responsibilities, and we have learned that mainly center's role, or the central government's role is mainly to formulate policies or give adequate funding and assistance and everything, and the actual execution is taken by another local, or mainly it's the ULBs which do the actual execution, and NGOs also support it. So yeah, so this reduces down to our option A, right? If all these are right, B is, C is, yeah, right. It reduces to option A. So yeah, so it's absolutely right. And when it comes to the Ministry of Drinking Water, so that is there responsible for, so it is there in the option itself. And yes, so this regulators role and NGO, so these are the main people who actually, like, at a physical level or at an execution level, when you physically see something being implemented, that usually comes through regulators or NGOs or ULBs, like urban local bodies, which are responsible, whereas the center or the state mainly overlooks all the process which is happening. They are the final authority from whom the approval and all assistance comes, but the main workers, like in monitoring of other sorry yeah, programs of capacity building, micro level management, all that is done through NGOs. So yeah, so that is right. So option A is the right answer. So let's go to the next question. That is which sorry, slide didn't change. Yeah, one second. I think this is time lag. Yeah. Which is the, oh, sorry, what is the design period for the sewage treatment plant in years governed by CPHEEO? So this, we've learned about design period. Firstly, what is design period? Supriya?
The maximum time, the time in which the treatment plants will get full, how to say, I don't know.
Yeah, you're right. Like, okay. So since we're mainly talking about treatment plant over here, yeah, treatment. But see, sewage treatment plants never get full because you're actually treating it and then it's going out, right? So you have continuous monitoring of that also, and we also talk about periodically how it should be maintained, how when it should be cleaned and all that. So design.
Design period is basically more about functionality. It should function and operational for that period. We should
Exactly.
consider all the aspects of design for that much period.
No,
Like
Exactly.
this much
it
pumps or motors or whatever XYZ is going to serve for that period.
Exactly.
Yeah,
Exactly.
it depends on projections also, for which what volume of population you are designing this treatment plan. Basically depends on the projections.
Correct, correct, absolutely. So design period we've learned in, if you remember in our initial lectures, we even calculated, like we even said, like this is the design period for these components, what it would be. So yeah, you're right. So it's mainly, it considers all the aspects before we are designing it, so that we are looking at for how many years will something be designed for any facility. That here we are talking about what this particular lecture we are talking about urban utilities, that is sanitation, water supply, all that. So any utility or any service that we are designing, how long will that service last, or for how long are we designing it? That is it. So as Supriya said, we will consider the population projection, the land use variations which is going to happen, the area availability. So there are so many factors which we will consider, and as Anurag was saying, the different components which are there also, that is what motor is there, what material we are using, whether that material will be able to stand for so long. So all these factors we will consider. So here, so, and we have already discussed that there are certain guidelines on how we would look at, because based on all these projections and land use variations and all, considering certain factors, certain guidelines have been given. That is, if you're designing a treatment plan, it should stay for so many years. So that one such guideline is the CPHEO guideline, which is given. So so this one, they mainly asking about sewage treatment plant. Like for a treatment plant, what should be the duration, or how, what should be the design period? So Supriya, any guesses on what this is?
No, it's 15 years, I guess.
Okay, it is 15 years. Fine. So we learned about long-term or like long-term planning, like for a long duration, design period being long-term, short-term, and then we learned about medium-term. So what were these? Do you remember? Anybody? Long-term is approximately how many years?
It's 20 plus. Short is 10, 10 I think.
Uh,
Medium,
no.
What is 5?
Short is 5 years, right?
Long is, I guess, something beyond
Years, 30 years. Long is
30
30.
years.
Yeah. Long is 30 years and medium is
15.
15.
yeah, medium is 15. So this is the standard which is followed. So it's not plus also, like it's just 30 years. Like long term means anything that we are designing for, usually it's around 30 years. More than 30 years, as we have discussed, mostly we don't design anything because there will be a lot of variations which can happen for more than 30 years, especially like treatment plants or in the sense when it comes to water supply, drainage, sanitation, and all that.
Things
Usually
may
the
not sustain. Things may not
exactly.
sustain beyond that time.
Exactly, because it's in continuous use and it involves a lot of chemical and water components and all that. So usually it is 30 years, which is a design period, which is taken as long term, and other short term components and medium term components are also there. So here we it is a medium term component, like sewage treatment plant is considered as a medium term component, and it is 15 years, which is considered. So this is from the CPHEO guideline. So for different factors whatever is taken. So as Supriya was saying, we take the population projection also. So considering that, we take land acquisition also, like that is how much of land will be available for that. So for that, we will look at 30 years or more. Like after 30 years also, will that land be available? So this is the design period aspects which we take. So yeah, so these are some of the other factors. So here, the seventh one we have a sewage treatment plant. So this is for other uh, components in our sanitation system. So treatment plant is for 15 years. Fine. Uh, any doubts in this question? Okay, we'll proceed further. So next question is, which of the following statements or statement is or are true concerning the city's sanitation plan? So Anurag, do you want to take this question up?
Okay. It involves capacity building. It involves evaluation. Test. I guess B and D.
So you're saying B. So the question is which is true, okay? Which is true. So
True.
you're saying
Huh.
B is true, that it involves a determination of existing needs or demand or
Demands and
deficient.
deficit.
Okay, right. It makes sense. Like, yeah, what is it? Yes. And you're saying D, it involves capacity building. Okay, right. Why not A? It considers only long-term sewage project plans. Like, why is A not
Mm,
true?
Because saying that it's only considered long term,
Yeah,
which is not true. Like,
true. It makes sense.
eh,
Because of this word only, it creates a problem.
and it involves evaluation and monitoring of 100% sanitation status. We are not looking into 100% sanitation status all the time. Basically, we are more focused toward the demand and deficit. What is our supply capacity and what is the demand? We are looking more into that.
Okay, okay. So you're saying this is wrong, right? Fine. Let's look at what the S- Supriya, you want to add something?
It's B and D only.
Okay, you also feel it's BND. Fine. Let us look at the city sanitation plan as the Ministry of, like, from the report which is there. So, yes, so B is right. So, all that it involves capacity building, all that is right. But in wastewater management, it is also given that we want to look into coverage of toilets 100%, coverage of sewage network 100%, uh, efficiency of sewage 100%. So, all this and I think the question here was mainly asking about evaluation and monitoring of sanitation status. Yeah, so let's see whether that is also there. So quality of sewage treatment, extent of reuse, efficiency in okay, so efficiency in collection of sewage charges 90%. So a lot of other factors are given. So, but then this one, yeah. So here, if you see quality of sewage treatment also, they have given it as 100%. And I think It involves evaluation and monitoring of 100% sanitation. So from this, can we say that evaluation and monitoring of 100% sanitation also is taken into consideration?
Yes.
We can say. So the hence it's as Anurag was saying, uh, so your logic was okay, makes sense that you said that maybe 100% is not required, but as per a city sanitation plan, we are aiming at 100%. But the fact is, it is not, we have not been able to achieve it. That fact is true. But our aim or the plan or the report, whatever is being forwarded, aims at getting 100% sanitation. So all the so except A, all the options are right. That is, it involves determination of existing needs and evaluation and monitoring of 100% sanitation status is what we are looking for, and it involves capacity building also. So option B, C, and D are right. Okay, any doubts?
No.
Okay, fine, let's proceed. So match the following wastewater management parameters with service level benchmarks. ML, are you around? I can see you online. So, is am I audible to you? Can you take this question up? Okay, he's not responding. Fine. Yes. So, Supriya, do you want to take this question up?
Yes.
Yes. So,
Customer complaints is 20.
yeah. Actually, we just saw these now, right?
Yeah, and no, I didn't see that.
No, okay. We just discussed it now, right? The previous slide. Yeah, let's do. Okay,
I
customer
was
complaints is 20. Okay.
coverage of toilet will be 100%.
Coverage of toilet is 100%. Fine.
Reuse recycling 90 and efficiency will be 80.
Uh,
Collection will
But
wait.
should
Let's.
we
Mm,
coverage of toilet is 100%, but
yes,
extent of reuse and recycling of sewage should be 20%.
exactly. Yeah, yeah. This
And
is
the
wrong.
customer complaint is 80%.
What is 80%?
The redressal of customer complaints.
Redressal of customer. Okay, yeah. Efficiency in redressal of customer complaints. This should be 80%. Fine. Yeah. And efficiency in collection of sewage charge will be
90%.
90%. So basically, option D is what we're
D.
talking about. Yeah, option D is what we're talking about. So yeah, so just going back, this is what we saw in the previous slide also. I've just put it here. So coverage of toilets 100%. Then we're what else were we talking about? Yeah, efficiency in addressal of customer complaints, it is 80%, and extent of reuse and recycling of sewage is 20%. And yeah, efficiency in collection of sewage charges is 90%. Fine, so these were the options which we had. Fine, let's proceed further. So this was the answer. And yeah, which of the following statements is not an example of on-site sanitation system? Uh, so yeah, so Anurag, do you want to take this question?
Small bore sewer system.
Small bore sewer system is not an on-site sanitation system. Fine. So leach pit, soak pit, and septic tank are on-site. Is that what you're saying, right?
Yes.
Okay. So Priya, any difference in opinion?
What is his answer? I didn't listen.
A was his answer, or what is your answer?
It's leach pit.
Okay, you're saying leach pit is not an on-site. Sorry. Leach pit is not an on-site. Fine. Let's see. So, small bore sewer system. It's basically an off-site treatment unit. So you have, so you basically have a small bore which is designed and it conveys the like whatever is designed for conveying only the settled sewage, mostly which is water, and at a low velocity. And it is from our normal pit. It is sorry. Went to a different slide. Yeah. Um, One second. Yeah. So it's conveyed and offsite at again, sorry, slide is keeping on changing. Yeah. So from an offsite place, the treatment happens in an other place. So there is a collection and conveyance of effluents from septic tank or any other aqua previous to the other places. So it is not on-site, it is off-site. So Anurag's answer was actually right, that it is a small bore sewer system, which is right. So we have also learned this, that why it is useful, because then it basically combines our central or completely decentralized normal decentralized system, and it is between a mix of what do you say, of on-site system and completely off-site system. It somewhere lies in between. It is an off-site system, but it is not like, it does not carry the whole thing outside, but it's designed for conveying only the settled sewage. So this actually helps in reducing cost in terms of mainly the excavation, slope, material treatment and all, because only a part of it is taken. So basically it's an upgrade from the on-site system, but it is not to the level of the conventional system. So it's somewhere in between. And for new areas when you're developing, we can start off with this and then later develop onto the normal conventional system. And so, as Supriya said, spoke about leach pits, let's look into why leach pit is not the right answer. Because leach pit basically means it's a pit, and it has and whatever it settles, and it's allowed to leach out the water or the whatever water is there which is remaining. It it is infiltrated, or the waste liquids is infiltrated out into the um, ground or soil, like that's how it goes out. So it is a standalone system. It doesn't need to convey this water to any other place. And then we've also learned that there's a wet pit, there's a dry pit also for this. And yeah, so this is from the lecture. We have already discussed all this. So the point is that leach pit is an standalone system or an on-site system, and it is not an off-site system. And we also have secondary treatment like soak pits, and also one of the option was soak pit. So soak pit is also a on-site system. It does not have anything connected. So we have learned this also, that you have an inlet and then you have a soak pit, and here it is normal sand, whereas here it is brick. So once the water or after draining, the waste liquid will come out and it will slowly spread through the rubble and it will go through the sand and it will just go away. So this is how we design it. Then we have the septic tank also. So this also we know that it is a separate standalone system or an on-site system. Right. So any doubts in that particular question? Shall we move on to this next question? Yeah, so I'm proceeding. So the
Yeah.
optimal pit emptying frequency of a leach pit is. So Supriya, do you want to take this up?
Now 1.5 to 3 years.
Yeah, 1.5 to 3 years. Anurag, what do you think?
I'm also with the same
Okay.
1.5 to 3
Okay.
years.
So can one of you say why it is 1.5 to 3 years, like any logical reason? Okay, so we have learned this in our lecture also, that it is 1.5 to 3 years. So let's just see that. So we have, I mean, the same slide. So optimal pit emptying frequency is 1.5 to 3 years. So one of the logic which why 1.5 to 3 years would be, so the minimum period for effective pathogen destruction is 1.5 years. So you actually need to keep it for like within after 1.5, you need to keep cleaning it. And yeah, so 3 years you're saying because it should not accumulate more also. So when we're using a leach pit, so that destruction would happen in 1.5. So after 1.5 years, you can start cleaning it. And like less than that, if you do, it won't be treated, or that the whole effect of putting a leach pit, we will not get it. So we'll be doing it in between. We would be removing it off. So every 1.5 to 3 years, if you periodically keep cleaning it, then it would be the best. Right. So let's proceed further. Infiltration area required for infiltration of waste liquids in the leach pit is given by which of the following formulas? Anurag?
total flow input every day
Yes,
per infiltration rate.
yes, right. Supriya, any difference in opinion?
No, the same answer.
Yeah, so this we just saw in the previous slide also that it was there here, I think. Yeah, the total flow per day divided by infiltration rate. So this is the infiltration area which is required. So that's just the formula they have asked in this question. So let's proceed further. What is the minimum number of dispersion trenches to be provided if the area required for dispersion trench is 90 meters square? Consider the width of the dispersion trench is 1 meter square. So yeah, so this is a very small numerical, very easy one. Supriya, do you want to take this up?
It's 3. Answer is 3.
Yeah, can you explain why?
30-meter width is the maximum, so we have 90 meter square
Yeah,
divided by 1 meter width, so it will 90 by 3, 90 by 30, it is 3.
3, correct. So what if it was 80? What would be the answer then?
Then also it will be 3,
Why?
because 30 meter is the maximum size, so we can't go above this.
Right, exactly. So you need to round it off. That is, you might get like some 2 point, sorry. Yeah, so even if you get 2.1, then it will be 3, like when you're dividing. So here you're correctly getting 3, so it's okay. But even if it is 2.1, then you'll have to take it to 3. Like you'll have to go to, not rounding, you'll have to go to the upper place. Fine. So next question. Dash filter is a fixed bed biological reactor. Uh,
Upflow anaerobic.
okay, right. Upflow anaerobic. Let's see. Why not others? Like, what is upflow aerobic filter? I mean, does such a filter exist? In sanitation, we're mainly not using such a filter. Like upflow aerobic filter, we do not use. It's always upflow anaerobic filter because there is no oxygen being involved over there. It's anaerobic process which is happening. And what is a trickling filter? Any idea? Okay, so trickling filter. So yeah, so this is upflow anaerobic filter. We have this is from the lecture we have discussed. So here there can be yeah, it can be integrated with the septic tank or it can be a stand. Yeah, so let's just go back to this. We will come to trickling filter. Do not worry. Let's just go back. What is a fixed bed biological reactor? Like, why is it called a fixed bed biological reactor? Any idea? Okay, so mainly here we are, if you look at the other, some react, okay, so here what we usually mean by a fixed bed is that you actually have a fixed bed or a fixed area which is designated for some catalytic action to happen or some reaction to happen. You are designating certain fixed positions. That is probably in this chamber or this area, this reaction would happen. So it is fixed and it's a fixed bed you call it. So it's mainly used in wastewater treatment and other chemical reactions. Also, a fixed bed treatments are used. So here, why anaerobic filter becomes so here also we have just learned that it is anaerobic filter is a fixed bed biological reactor. Why? Mainly because you have a fixed chamber or a fixed region, and we are talking about certain chemical reactions which are happening within that region, and we are getting the effluent out of it. So it can be integrated with our septic tank. So in this is the case where it's integrated with the septic tank. So here also you observe there's a fixed chamber for it or something else is being constructed. And there can be multi-chamber anaerobic filter also where each chamber something is happening. So this is the reason why we called it a fixed bed biological reactor, which is happening over there. And when it comes to our trickling filter, so let's go to our trickling filter. So in trickling filter, it is also a waste water treatment type, and it is one of the oldest and the most well characterized technologies also. So here, what is happening is there's a lot of motion which is happening, and water just keeps moving on like up and so mainly. So if you look, it water or the influent comes in through here and it goes up, and then there's a rotating influent distributor, And from here again it goes, and through this medium there is some filtration which is happening, and whatever the after the filtered effluent, it comes down, and then we are using a clarifier. So this we learned, like why do we use a in the previous class we have discussed, we use a clarifier, and that sludge is removed and the treated water is going. So if you notice, this is not I mean, you wouldn't call it a fixed bed, because it's actually going up and then it's coming down, so you have some motion happening there. And in different places no chemical reaction is happening in this particular case. It's just over here there is some filtration which is happening. So yeah, so that's all about this one, trickling filter. And yeah, so what else was there in our, yeah, so the last one was gravity filter. So this we have learned in our previous session. We spoke about our gravity pumps and all that. So gravity filter mainly makes use of gravity and it filters in the process. So this one mainly talks about fixed bed biological reactor, and there is only one biological reactor which is happening over here, that is the upflow anaerobic filter. Fine. So which question am I? Yeah, 14th question. Yeah, so match the following sewage management systems with its functioning mechanism. Uh, yeah, so who wants to take up this question? We have only two more questions left. I forgot who was
It's
on.
B.
Ah,
Answer is B.
answer is B. Okay, came up with the answer also. Fine, let's see.
But
So,
C is written 6. It would be 4.
acha, yeah, okay, this is a type. My mistake probably. Yeah,
Yeah,
it should
it's
be
type
4. Yeah.
ordering.
Cool. Yeah. So, okay. So let's go package septic tank with contact aeration type system. You're saying it is 3. That is, it uses fixed film plastic medium with high specific area, along with continuous diffusion of controlled air. Okay. And aqua privy, it is according to this one, it would be 2 aerobic digestion chamber and filter chamber is involved in the treatment. Yeah, so this is actually directly from our lecture, right? The definition which is given directly, it's been asked. And chemical toilet, it involves caustic soda. Yeah, so whatever involves caustic soda, yeah, that is the chemical toilet. And multi-chamber anaerobic filter with septic tank becomes our anaerobic filter is employed with. Okay, so this, yeah, this is what anaerobic filter is, what we were just discussing right now. So, yeah, so this option is right. Any doubts in this particular question? We can proceed further. I think we can proceed further. This was a very simple question. So, yeah, so this is our last question also. Which of the following statements is or are false for a decentralized sewerage system? So, Anurag, do you want to take this up?
One second.
Okay, let's go option by option. Is it suitable for low density communities where STP capacity is limited? So we're mainly talking
Yes.
about decentralized system. Yeah, fine. It is suitable. It is suitable for low density communities and provides localized water reuse opportunities. Does it?
Yes. We up to some extent.
Okay, so is it option right or wrong? What do you think? Does it support low
Yeah.
density communities and provides
Yeah.
localized water reuse opportunities?
It is right, I guess.
Okay. Now, is it suitable where STP capacity is limited, but targeted treatment for specific sewage constituents is not possible? Is it not possible? Okay, let's break the sentence. Is it suitable where STP capacity is limited?
Yes.
Okay, first part
Yes.
is right. Second part, targeted treatment for specific sewage constituents is not possible.
This
No, it
this
is
option
possible.
not. It
Uh,
is possible. I mean,
Okay, let's come back to that. What about D? Is it suitable where STP capacity can be expanded and targeted treatment for specific sewage components is possible? So it's basically related to this only, yeah. So here it's saying
so
STP
maybe
capacity is
C.
limited, STP capacity is expanded and targeted. So, okay, see, fine. Is D right or wrong?
D is right, C is wrong, and I
C
guess
is partially right, partially wrong.
Yeah, so if you have to choose which is false, then there's no partial,
C,
right? It
yeah,
has
C
to be wrong.
is false.
Yeah, so we have arrived at C. Let's also because let's also look at what we learned so that we are clear about the concept. So this is what we learned. So yes, so decentralized sewage systems treat, reuse, or dispose sewage near to source of generation. So we don't have to take it to another place like centralized system. So from the figure they've learned, there is only one STP for a centralized system, but for a decentralized system, you have multiple STPs. Plus, you also have certain on-site systems also. So that is what a decentralized system, and because of this, we even call it an incremental system also because it has all different multiple components also within it. So now these are suitable for small and low density communities. This was one of our options. Yes, and buildings in isolated areas and sometimes even existing in developed areas. So this was right. We put it as right. Now, so where it is suitable in places where STP capacity is limited and expansion is not possible. So this is what we said. Partially it is right. Yes, where it is limited, it is there. And also now the treatment part where we were discussing. So it is said that targeted treatment for specific sewage constituents is possible. So as we correctly said that over here where they say that targeted treatment for sewage specific components is not possible is wrong. So this option is, so what we have arrived was correct. That is option C is the wrong answer. So Anurag was a bit confused in option B, but yes, it is right. That is for low density communities and it provides localized water reuse opportunities also because it has on-site, so any on-site system can also be employed in a decentralized sewerage system. So local reuse opportunities are also there. And you have local STPs also, so that also allows a local reuse opportunity. Right. So we have come to the end of all our questions. So now if you have any doubts in whatever we discussed or this entire week session or previous sessions also that is in your assignments or anything, you can ask now. No doubts, right? Okay, that's good to know. Uh, I hope you were able to complete previous assignments fully, like, and submitted, and there were no errors in this time's assignment, right?
no, no.
Okay. Supriya, did you get that error sorted? That is, you had some doubt in assignment 5 or something, right?
Uh, which one? I don't. I
No, no.
forgot.
Last class, which I discussed, you said you might have missed the question. You were talking about maybe it's a
I
different question.
I didn't see. I didn't go back.
Okay, okay. So yeah, so I think today they've released all the solutions, right? So you can go through that and then in case anything, you can ask in next class also. Because in the discussion forum, I saw that you had asked some doubt. That's it. Right. Uh, cool. Then, if that's it, we will wind up for today. Uh, so see you all next week. And yeah, as always, if you have any doubts, you can always put it in the discussion forum. We will come and discuss some. We'll either reply there or in the tutorial session like this, we can have the discussion. So yeah, so have a nice day. Okay, day is almost over, so have a good evening. Bye.
Bye. Thank you.
Bye. Thank you.